Okay, we're going to start. Hello, everyone. Thank you for joining us today. This is a joint session between Madrid-Java user group and Madrid-GUG user group. I'm Ivan from the GUG user group. And we have here Sven. It's our pleasure to have him here. I will let him introduce himself. I just want to mention that his talk is part of the JUG Tour he is doing in Spain. Last week, he went to, I think, Vigo, Coruña, Seville, and Malaga. And this week, Valencia, Barcelona,
Madrid,
today Madrid,
Coimbra.
Okay, and tomorrow he ends the tour in Coimbra, in Portugal. So it's great to have you here. And just a reminder, at the end of the talk, please don't leave. We have a lot of things to raffle. We have IntelliJ licenses. There are a lot of stickers, some T-shirts. I have a mug from Madrid-GUG user group. We also have some tickets for next week. It's Codemotion Madrid. We have premium tickets for the online conference. So if you are interested in getting one of them, please stay at the end of the talk. And I think that's it. It's all yours. Thank you.
Thank you very much. So, yes, let's go here to something. Another critical part, I have to start my presentation. So let's see where it is and start. Oh, as we can see, we see nothing. That's not good. Oh, okay, it's working somehow. It's working. So it's always, if you have shared screens and then some recording and StreamYard and Zoom and all this stuff, it's just messing up this stuff. So, yeah. I think everybody is aware of Java. Yes, even if you're coming from the Groovy group. And this isn't quite old language, and you can do a lot of stuff with this old language, even if you have all this syntactic sugar now coming up with every 6 months, or what's the latest release cycle? I think 6 months, huh? 6 months, yeah. So during the time I started with Java, 1996, it was every release every 5 years or so. It was a little bit slower. Okay, so my name is Sven. I'm working for JFrog. And JFrog is famous for the shirts, okay? And by the way, we are on the other side, we are creating Artifactory. It's this repository manager and all this stuff. And I'm personally focusing there as developer advocate for the security part. So mostly I'm focusing on cybersecurity stuff, what you need to fight against vulnerabilities, malicious code packages, and all this stuff. So that's the X-ray part. Yeah, so if you want to contact me later, because you have questions or whatever, you can use Twitter, Mastodon now, since a few days, so feel free. I'm on mastodon.social, this server, well, you will find me. And otherwise, I'm on YouTube. And if you want to contact me, please don't use email, okay? No email, no email, definitely, because it's a mess. It's just, forget it. Okay, so let's start. If you want to have something like this, well, so we're here to grab a shirt, go to this URL, and then you can get a shirt. It will be sent by mail. It's not this one, it's another one. It's this Bunbury's Frogs, this one. And the first 5 will get the book as well. I'm not selecting this 5 because it's not allowed, and we are a public company and all this stuff. So someone will select it in US with all the rules that are necessary for this, and will inform you. Okay. Yesterday, I got a question about the T-shirt size. Is this European or is this US? I have no clue. Okay. I was not able to identify it. And, well, I think European size. So, just one thing before I'm starting. Who of you is using Twitter or LinkedIn or stuff like this? Okay. Do me a favor. Since we're all starting with this real events again, I see so many JUGs and communities struggling that they have a history of 10 years, but they are starting more or less from scratch. And if you're here a big thank you to the organizers. And what you can give back is that you are making some pictures, writing something and sharing it on Twitter, on LinkedIn, and all this stuff. If you add in JFrog, JFrog will retweet. If I see that I'm somewhere mentioned, I will retweet as well. And feel free to connect to the other JUGs. So they organize all together this tool and just give something back. It would be a pleasure to see some stuff in social media. So it's something you can give back, because if other people in your area will see it, maybe they are joining, they are coming back, say to your colleagues, invite them, all this stuff. Okay, so it helps the organizers to grow again. It was a tough time with COVID, I think. Okay, so proxies. We are talking about proxies today. Who knows what a proxy is? Are you sure? Okay. Okay. Who's using proxies? Yeah, it's a good question. Proxy in general is a very wide range, no? But we are talking now proxies in Java, and more or less, mostly everybody is using it directly or indirectly, you know, this kind of proxies. I will show you how to make these proxies with your own fingers. This presentation is based on a book I wrote with Heinz Kapputz, I don't know how many years ago. And there is a new version of this book. Heinz wrote a new version and published it somewhere. And I'm just covering the stuff from the first book because I was involved in the first version, yeah? And maybe in the new version there are some additional stuff. But anyway, it's enough stuff here. So, why should I use a proxy? Well, you're dividing things, okay? A proxy is more or less something like a representative that is doing something in behalf of, like I don't know, something, no? Standing here, redirecting, standing here and representing something. So what you're using is you try to decouple with proxy stuff. You try to implement cross-domain topics maybe with proxies. Yeah? If you want to sneak in with something, most people know it with lazy loading or authorization or whatever, okay? And proxies are good to hide technical stuff, technical implementations. So then a proxy must be easy to use. Means, I'm switching here a little bit so that I can click it a little bit better. Don't look too much at the class names, okay? They are just for presentation. It's not what I'm recommending in production code, okay? These class names are optimized for reading on slides, not on refactoring and other useful stuff. Let's imagine you have some class, okay? And then you have some interface that is defining all the methods and all this stuff, okay? It would be cool if you would have a proxy like, for example, a method that is able to create a proxy. Now the question, what kind of proxy? Okay. And you would be able to do something like this. You could add logging, for example. You could add metrics, measurement, stuff like this. You could add, as next, for example, security rules, a very interesting security rule, and maybe the second one, okay? But I think you got the point, okay? It would be nice if you could have different proxies that you're building in an easy way, supported by an IDE, supported by native language constructions without any magic, and then say, okay, now it's time to build it. We are coming back to this builder, why I'm using a builder for this, okay? Because with this, we're able to do a cool thing that we are not able to do in traditional way with proxies. Okay, so otherwise, it could be more like this. Long time, this was very fancy. And then in the Spring universe, I think you have annotations and code, okay? Something like this. I don't know if it is still there, but it would be interesting if you can combine it with techniques like dependency injection or whatever, and then you can customize this, but it's still inside the static semantics so that you have an idea what's going on, okay? So, for example, make a virtual proxy, what it is, we are covering, and then add metrics, for example, stuff like this. So, this would be nice. What is the difference between proxy and an adapter? An adapter, that is something that's wrapping something, and it is changing the signature, okay? It's to adopt to something, because you have a, instead of a list, you want to have a collection on a stream or whatever. So you're changing something. But an adapter has no logic inside, okay? I see quite often that people are mixing it up, changing the signature and adding functionality. Not good. Okay? Using an adapter as an adapter, using proxy as a proxy, please. By the way, if you have any questions, feel free to ask. Okay? So we don't have to wait until the Q&A phase or in the beginning. Okay? So then let's go. This is a legacy worker, some old code. Okay? And you have there this string array, for example. And then you want to have an adapter because you want to switch to list. This is exactly an adapter, okay? It's very simplified, but it's an adapter. And then to use this adapter, what you need to do, you have a reference to the legacy implementation, so you need access to the instance somehow, maybe holding it internally, if you're not injecting or doing magic to get access to it. And then the only thing what you're doing inside the adapter is switching the method signature, nothing else. Nothing add, nothing remove, nothing, okay? That's the only logic that should be inside an adapter. Okay, here now, from string to list, if it does make sense or not, I don't discuss this right now. And then this is the only functionality of this adapter. Okay, good, and we have this legacy worker. So, let's see, there is the main hello world with this array list. We are putting all this stuff in a collection, if that makes sense or not, and then we are using this adapter, we're instantiating this adapter. With the instantiation, what we need, immediately the instantiation of the thing I want to delegate through. So the lifeline of an adapter and the thing I want to delegate through is mostly bound together. Mostly, okay? It starts together, it ends together. You can break it, but it's mostly the thing, okay? So, and then here's the instance, and then do something. Okay. The only thing is, no need to know the legacy worker means that if you're using the adapter, you're hiding completely the internals. Okay. At this point, you have no clue about what's internally used. This is good to hide something because you want to have a different interface from outside. Okay. So, another thing is that between adapter and the legacy implementation, there is no inheritance. Yeah, sure, you want to decouple this stuff. Okay, it makes no sense to bring some kind of inheritance here. Please don't do it. Okay? Otherwise, the old signature was bleeding out of this adapter because it would be available. Okay? So, and only transformation of an interface, it's, well, if you're working with interfaces, but I mean the method signature here. Okay, so this I mentioned already, lifeline is the same. And now we need a few steps to switch now to a proxy. I will create the first useless proxy that has a minimum requirement to be a proxy. Okay. And this is, we need to know the legacy worker, yes, because we are not switching the method signature. So I have full knowledge about all the stuff I'm having here. Then there is an inheritance because a proxy is a replacement. There must be at least one interface that is connecting both. Okay, so that you can replace it at this part. Okay. So then don't use it like an adapter. As I mentioned, don't change the signatures and don't add signatures for the functionality. Okay, if you have something to add metrics and all this stuff, think about how you can hide it, because it should be really a drop-in replacement without bleeding out the functionality of the proxy itself. Okay? If it is a metrics proxy, you don't want to have after this an instance with switch metrics on, switch metrics off. Okay? You don't want to have it. So this is why don't change the signature. So now, switching code. If this is my interface, very useful one, okay? Then my implementation could be something like this. It's just an implementation. And then the minimum to be in proxy is exactly this. I'm implementing, so I'm inside the inheritance, right? I'm implementing the method signature, I'm not changing it, right? And I have the possibility to redirect everything that's coming into the old implementation. That's exactly what a proxy is doing. This is a completely useless proxy, but it's the easiest version of a proxy, fulfilling all the requirements. So now we can start playing around what we want to do and what kind of proxies we have. For example, I'm touching here more or less 3 different main groups of proxies. The first one is a security proxy. What could be the task of a security proxy? Any idea? Sitting first row, yeah.
No, maybe a user or verify access, something like that.
Yeah, something with do something, if it is allowed or not. And what's the challenge here? Any ideas? Okay, let's see. So let's assume we have this service, okay? This is method work. Some string in, some string out, okay? Good. Now I want to make sure that I have a security proxy. It's executed only if it is allowed. Any idea what could be the challenge now? Okay, let's go. If this is the proxy, if it is inside inheritance, yes. It's delegating to the original, yes. It's not changing the signature, yes. And it's adding cross-domain topic, security. If it is allowed, yes or no. And what's the challenge here? Return values. For security proxies, you have always a challenge. What is a valid return type if it is not allowed to execute this method? That's it. Here, I'm just giving no back. Makes this sense? I have no clue. If you have an integer, what can you do? Mostly, I'm getting the answer, exception. Can be. Some people say 0. Mine is infinitive. Whatever. You have to think about it. It's not trivial. Okay? That's something you have to think about. Why? If you're using a security proxy, what would be the return type? So the implementation here is trivial. I'm not talking about this one. The next one, the next main group are remote proxies. I think it's not so common anymore. Longer time ago, it was very common because what you want to do with remote proxies, things should be executed somewhere. The earliest disaster was RMI. Then it was Java EE in the first version. No? So all this stuff that's happening somewhere. So what you want to do here with this stuff? So you have this implementation, and the next one, you want to execute something that is mostly out of your own process. You want to cross barriers, technical barriers. It could be in different process, could be a different machine, it could be something. So you want to decouple this running instance. That is a remote proxy. Okay. So now the question is, I'm showing very old implementation. If you have this remote proxy, you have this proxy you're invoking, and now the question, how to implement this. The main thing is, remote proxy is mostly used to hide technical complex things like serialization, deserialization, wrapping, unwrapping, communication channels, encrypting, and all this stuff. Because you want to communicate with something. Immediately, Java, still object-oriented, complex graphs, how to deal with complex graphs, how to serialize. By the way, if you have to deal with serialization, there is a cool open source project called MicroStream. And they are freaking cool in serializing, deserializing, because they are not using the traditional serializing technique, and they're not going this JSON way. And you can persist this stuff. It's a nice open source project. Have a look at this one. And it's fast. It's really fast. So we need some work to do. So mostly what we have is we have this remote communication. So we have interface on both sides, and then we have this technical part that's hiding all this stuff. It could be complex as much as you want. Okay. Mostly the target is that you don't see that you are working with a distributed system or remote instance. So you want to hide all this behavior, but have in mind latency and communication, it's still there. Okay, so that's more or less hiding technology. Okay, making things easy. And yeah, you want to hide this communication, more or less. So, and now we are coming to the most interesting group, virtual proxies. Because not always I have to deal with remote communication. I not always have to implement security and all this stuff. There are several different ways to implement this one. But virtual proxies, this is a big tool. This is something you can do a lot with, okay? Let's see. We have now this implementation. So this proxy, I have exactly this implementation. I'm delegating through it. And now the big question is, what is the target of a virtual proxy? So what I try to do, what I want to do with a virtual proxy. The basic thing is I want to decouple lifelines. Okay, I have somewhere a heavy object and I have somewhere a light white representative. And then if something is happening here, I start instantiating something. Now we can discuss how we are doing it effectively, but a virtual proxy is a lightweight instance that will give me access to a heavy object. That's it. Okay, so decoupling life cycles. Now it will be a little bit more. So creates the delegator later, so something, the heavy object. And this is a trivial implementation at the beginning. So what we are doing? What I'm doing here is I have this instance service, and this is null, okay? And then it's null until the first request is coming. The first request coming, then I'm checking, do we have this instance? If no, you're creating it once, hopefully, and then working on this stuff. How long should I hold this instance? How I'm creating this? Do I have different strategies to create? Can I? And so on and so on. Now, a bunch of questions are coming. Okay. Let's see. 0, other nothing, and then creating this heavy implementation later. Okay. First of all, what is crap with this implementation? First of all, this one. Okay. If I have multiple requests coming in, I have to deal with this, making sure that I'm really only instantiating one version, okay, not several. This is some kind of a strategy, okay? This is not thread safe, it's fine. Then I have this implementation, and here's a fixed decision how to create this stuff. Heavy objects tend to have some kind of initialization, difficult word, okay? This init process, okay? Make it simple. So how to configure this heavy object? It's just a constructor, yes or no, okay? So we are working on this because we have different strategies. The strategy, how often and what's the right time to start with the creation of this object and how to create this object itself. We have two things here and we should decouple it, okay? Because this is just too hard. And then this is exactly the strategy how to create. Huh? Okay. So 3 things. What's the right implementation to invoke it, how to invoke it, and what's the right time and strategy to do it. 3 things, not only 2, 3. Okay, corrected. Okay, so let's see. If I have this one, okay, then this could be a service factory. The new operator is nothing else. It's a strategy to create something new, done, default constructor. Okay. If I now want to have a strategy, I have a thing to configure, I have to read something, I have to whatever, then I could extract it in a service factory and say, okay, now I have an instance to create this instance and method. And then I can implement there the way how to create this stuff. Okay. Here, it's a strategy itself. Okay. It means I can say, okay, I have this service strategy factory. It's exactly how to create this stuff or what is the right time to create it. Okay. If it is synchronized, if it is just randomly, if it is whatever. If I'm combining both now, what I can do is I can implement the strategies independently. For example, here, I'm just invoking the new operator. It's okay. It's one valid strategy to create this object. And the other one is that I'm saying, okay, what I had before now, if it is null, implement. What I have reached with this, I start minimizing, recreating again and again the same stuff. If I have different strategies to create the object, I can implement them, test them individually, and then I'm just using it instead of re-implementing with every proxy the same stuff. Copy, paste, copy, paste, copy, paste. The same with a decision. What is the right strategy? Synchronize, thread safe, whatever. Okay, and this I can implement individually and then reusing it. So let's create something like this. So I know how to implement. I know what's the strategy. And then the invocation is the strategy creates a real object and get the information how to do it and is invocating the method. Okay, that's it. Now everything is decoupled. Great. And I can test it individually. Okay. With this in mind, we can do now crazy things. If I want to have a synchronous thing, the only thing what I should do, I'm reusing how to create this object, or already in reusage. And then the strategy, I'm just saying, okay, I'm synchronizing it now. If it makes sense or not, I don't care. But I think you get the point. Now you start reusing existing stuff and you can focus on dedicated single things. By the way easier to create mutation test coverage against this implementation compared to the complete mixed up implementation. Okay, so that's it. What can we do? For example, I can say, I want to create this new instance, as we have done before. And now what I'm doing is I'm implementing this one. What's going on here? With every request, I'm creating a new instance because I don't want to reuse this instance maybe, okay? Because it's an, I don't know, whatever, you need it. Yeah? Okay, so that's one thing. Next thing, how to combine proxies. If I have a proxy, a security one, remote one, and a virtual one, and I have different of them, how can I combine them? Because I can cascade them. Which of this combination makes no sense? So, going remote and then creating virtual proxy and then deciding if it is allowed or not is mostly not very useful. Security should be done first, because then you're minimizing the invocation. The next one, creating first a virtual proxy and then decide if it is allowed, makes no sense. So it means cascading proxies is easy because you're wrapping the stuff together, but you need a strategy so that your colleagues and yourself, you're not doing stupid stuff and messing up the whole system. And with annotations and just thinking about the order of annotation and how they are processed and all this stuff, I see quite often that proxies are just in a stupid order created and they're not really giving you the full potential, what they can do. So we have to think about how to cascade proxies. Let's have an example. I have the security proxy and I have a virtual proxy. Just the easy implementation we had before. There's, okay, I'm checking something and then if there's a first request, go. I'm not discussing about multi-threading and all this stuff, okay? It's just how to combine proxies from the idea. So if I have this one, I have here this virtual proxy, and this virtual proxy is using this implementation, okay, as we have done it before, but I have a secure virtual proxy. So if you're combining proxies, it would be good if the name of this proxy really represents the strategy, which one first, second, third, and so on. Otherwise, it's just a mess. The bad thing here is that with this combination of proxies, the secure proxy and the virtual proxy are really hard-bound. They're just hard-written together. Maybe for the first draft, it's nice, but in the end, it's producing a huge combination of the same stuff. How to get rid of this? Okay. So here, no, this is a bad code here, no, because we are writing this stuff together. So this hardwired proxies, we have to get rid of this. What can we do? So during the time I create these slides, they're quite old. I was so happy with all these animations. Sorry for this, okay? And the colors, I'm not a designer. We need a generic proxy, okay? And the next thing is, we have this generic proxy since a long, long time. Who started even with 1.2 or 1.3? Who started later? So it's there for ages, okay? Oh man, time is flying. The dynamic proxy is an old thing, but still cool because you can remove a lot of boilerplate code. How to do this? So, dynamic proxies. How to use it? We have this proxy based on reflection. It's still not so bad, okay? You can use it, even if a lot of people say reflection is bad. Yeah? It's not so bad. You need an interface, okay? That's a contract between the implementation, proxy, and all this stuff. Then we need the implementation itself that should be used to delegate through, doing the actual work, okay? And this is how it looks like. Clear? No, definitely not. We will go there step by step. So, first of all, I have the service class cast. That means I'm casting to this interface, okay? Just a way to cast. Then, I'm using this proxy.new proxy instance as a static method. Just there, you have to use it. We're not discussing about it, you have to use it like this, that's it. Then, you have to define what's the right class loader. Who's still thinking about class loading? It's this old thing, huh? Class loading. No, it's actually useful sometimes. And then I have this array of classes. Oh man, what I'm doing with this. Okay, I have nothing to point, but I mean, this strange thing here in the middle, okay? So what I'm doing with this, or what can I do? I can use a bunch of interfaces I want to make in one proxy, okay? So you can have an array of interfaces. Then I need something that is doing the work. That's the invocation handler, okay? This is a thing that will be invoked dynamically with reflection, okay? And in this, I'm writing all this stuff I want to do. And here you see this invoke, this message, invoke, object, method, arguments. It's generic, or in a way generic written, so that you have to know a little bit about reflection. That's not so bad. So you have this object with proxy, then you have all the signatures, then you have to pack both together. That's the first thing. We will mess it up, don't worry. And then you're invoking it. So now we have the possibility to create proxies on the fly without hard coding it. We have a little bit trade-off in runtime. We will see how we can get rid of this runtime trade-off later. Okay, so how to make a virtual proxy. What is a place to implement the strategy and all this stuff? It's the invocation handler. It's exactly where you're implementing the stuff that should happen. Okay, so let's go. We have now this invocation handler. So stuff is coming in, this proxy, the method, and the arguments. Then you have something to do. You're checking if it is null or not, and then invoking and using this one. So it means you have here the implementation, and then you're calling it, and that's it. What else can we do? If I have now a generic way to create proxies at runtime, I can do stuff. This is bad, and this is bad. Why? I want to have it more generic, huh? Who's playing around with generics? I heard it. I heard it. I heard it. So, this I want to have from outside. I don't want to have it in static semantic. I want to extract it. Okay? Then I can use it dynamically. I really heard it. And this one, I have to remove it because I want to bring it from outside. I want to dynamically decide what is the strategy, what is the instance, and all this stuff. Okay. So, and then this instance. I just need this instance. So I want to have it from somewhere. Okay. I call it proxy generator. Now we again, next step. Instead of coding all this stuff, think a little bit, and then you can implement cool stuff. I'm using this one. I have this proxy generator, and now I'm going over generics. During the static invocation of this make proxy, I can type this stuff. The type interference in Java is good enough to do this. Okay. Now I can give from outside the class I want to have as the output, and I can put all this stuff more or less in. So that's it. Oh, a little bit bigger. So I have the subject, I'm creating this new instance, getting class loader, blah, blah, blah. First thing. Now I'm working with generics. What can we do as next? So if I'm now able to do this, I'm able to minimize a bunch of code because I don't have to implement for all interfaces this dynamic proxy and this invocation. So I just have one, and then I can use it declarative. I can just make it on the fly. With reflection on the fly, I can decide what interface I want to have to create a proxy. That's stuff. Huh? Okay, we can create all these different proxies we want because I can put everything in. But how to combine these proxies? The challenge is that you don't put all this stuff in one proxy. So how to combine now different proxies in a generic way that you are just writing what you need instead of endless giving all these permutations somewhere in the code because you have to maintain it, okay? Okay, so from the factory method pattern, we have to switch to builder pattern because it's an old one, everybody knows it, IDE is supporting it well. Huh? So how to do this one? Let's have the idea. I want to have a security proxy, and security proxy that's leading to a virtual proxy. Now I have different ways to implement it. The first one could be, I'm mixing them up two security proxies and creating one virtual proxy. Huh? That's one thing. The other thing is, I can create for every step, for every rule, an independent proxy. And the last one is exactly what I'm recommending. If you have different tasks of the same type, like security, do a security proxy plus a security proxy so that you have atomic, single atomic operations. Yeah? Makes things way, way easier. I call it cascaded proxy. Okay? I have to find names, sorry. And I'm not good in finding names. Too generic, I know. Okay, so let's go. So if I have now a proxy and I want to cascade this stuff, I have two ways to do it. I can do it bottom up or top down. Okay? Now the question, what's from the semantic point of view better? What's easier to handle? Okay? Nevertheless, you have to decide it. I've done the decision by myself. So, for example, I want to add different security rules, okay? So I have this security rule that's just checking something magically, having access to whatever, and giving back true or false. That's it, okay? Make it simple. Now, I have this functional interface. Cool, because now I can play around with lambdas. Oh man, the next stuff, huh? I have now a list of security rules. Somewhere, someone is defining rule A, B, C, D, E, F, G. I have access to it. Here it's just the list. Could be a stream, could be whatever, okay? So my resource, where I'm getting all this stuff, here I'm doing it reverse because I'm going bottom up, okay? And then for each of the security rules, I want to invoke something that is building this stuff, or it's invoking. So the method name is crap. It's really optimized for reading on slides, yeah? Don't use its names later in source code. Okay, so how to do this? The gray stuff is the generic stuff for using dynamic proxies. Okay, but the invocation handler is now what I want to have. I have this proxy builder and redirecting to the original. The original I want to invoke at some point, okay? Yeah, Slack. I don't know how to get rid of, not Slack, but this stuff. If I'm invoking something, I have a rule I'm checking. Based on the result, I follow up or I break, okay? And then I have to cascade it somehow. What I'm doing here is that I'm just setting the next proxy as original, and so I'm cascading the invocation. Not so fancy, okay? It's just going step by step down. You can do it in a tree, not only in a list. Okay, so here's the original. This is what I'm changing. It's the last child. This is what I'm invoking. So I'm cascading this stuff. And then I'm just setting the next one. Done. It's a generic way to cascade stuff with generics. Because proxy builder, you can type it on the fly. Good. So if I can cascade proxies, how to do it with different proxies, how this will be used. Let's see. I have this original, the implementation. I have this logic, this interface that's going through, and I have this create thing. I'm giving the interface, I'm giving the original, then I'm adding something, adding metrics, and so on. And this is exactly what I'm saying. Using a builder pattern to cascade proxies is good. If you have a checked builder, for example, you can do something like, you can invoke methods only in a certain order, or you can just invoke things that in combination make sense. You can implement rules for or against useless combinations, all this stuff, okay? So using a traditional builder pattern to give all your colleagues a good way to use this makes it very convenient. And then I don't have to think about how to cascade a logging proxy and all this stuff. I'm just invoking it. Even if I can invoke logging metrics in a different order, inside the builder, I can implement the logic how to verify what's the right order of the proxies. Okay? So it's completely transparent for all the people that are just using it. And the IDE support is perfect because just call Java. Huh? Okay? Good. So, and then I'm adding different rules and then at some point build. Even this build method is interesting. We will see later. This is amazing. So, dynamic proxy building. So, we just cascaded one interface. But how to deal with different interfaces? Challenging. So, what I need is a generic nested builder. Why? If I have just the same interface, I can invoke the methods in a way I just want to invoke. If I have now different proxies with different needs, metrics, logging, security, I have to customize it. So I have to make sure that if I'm in the path of now creating the security proxy, I have only the methods to create or to add the stuff for the security proxy. If this definition is done, I want to switch back to the original builder. So I need something like a generic nested builder, so that my IDE is just presenting the methods that are actually making sense. Okay? Too weird? Not until now. Okay, let's go. It's just a few lines of code. Don't worry. Just a few lines of code. So let's assume we have something like this. We have a car. And this car has now an engine with a builder and a bunch of wheels. Okay? So mostly, if I'm just using builders, it ends up in code like the following. I have this car, and I want to say something with engine. And the next thing is that this engine is created somewhere with this builder, for example, with different attributes and saying build and all this stuff. Okay? Good. Now I want to have these wheels. Mostly I see something like this. I have a list of wheels or a collection or whatever. This is an Italian car. And then I'm adding these wheels in a list. I have a semantic break here, because I have a data structure and a bunch of builders. Not nice. And then for these wheels, oh man, I'm doing something like this. Great, huh? Wonderful. This is if you're using generate IDE support, well, going fast. So in the end, the code looks like this. And if I'm seeing this, I'm just ugly. We can work against this. Make it nice. The first thing is, I have to get rid of this one, this list of wheels. Huh? So dedicated instance and a collection. Why? If you want to get the full potential of extracting patterns a good first step is making everything equal. It's the same strategy. Instead of having a list of wheels and for each wheel a builder, I would introduce a wheel list, okay, and a builder for this. Now I have, again, a builder. Okay, now I'm just playing around with builders, okay? Now I can start extracting patterns because it's, I don't know the right English word, but it's always the same structure. It's always the same thing. I don't have the semantic break, okay? So, by the way, I can robust testing here, for example, during the build thing, that I have to add 4 wheels instead of 3. Now, check build, not covering here. So this one and this one is not so nice. I want to get rid of this boilerplate code and the need to combine it manually because I can do mistakes here. It just could go wrong. I could add the same instance twice or whatever, okay? So how to get rid of this? How to combine this? If I have now these 2 things, I would like to have something like, okay, get rid of this stuff. Sorry, it's the animation is horrible. I want to have something like this. I think the next slide is bringing it to the top. What I'm doing here, I just thought about if I have a builder for wheels, I'm implementing this builder. It would be nice if I can combine this builder with my parent builder in a way that I don't have to invocate the tiny builder and then adding all this stuff together. So I want to switch builders on the fly. How to make it so that I'm not writing repetitive code endlessly. Okay, so what I want to have this wheel list builder. Yeah, I'm switching everywhere to builder. Then I'm saying I want to add a new wheel. Now I'm not adding the same instance twice or whatever. Then I'm adding all these attributes, and the method add wheel to list is explicitly called add wheel to list so that you're not mixing it up with build. Okay, that's the only thing why I'm calling it add wheels to list. So that's very explicit and clear. So now what I can do is I'm in my IDE, I'm going to the next level, and then I have all the attributes for this dedicated entity I want to create, and I'm switching back. How to do this without magic? So much code, not more. So here I'm switching builder, and here I'm back to the wheel list builder. Because this behavior I need later to cascade proxies. Okay, this is why I'm going here through this. So, and then if I'm doing it for all layers, I would have a tree of builders with always a semantic change depending on the level I am. Okay, so we have to combine all this stuff. Oh, I have to get rid of this. So I want to have something like this. Here, this is way better to read. Or if you're reading something like this, you know exactly where you are, what you have, you can make the order clear and all this stuff. This is nice to read and less repetitive as the other one. Okay, good. So how I can switch between builders? I had more or less the first approach with adding different security rules. You remember? I'm switching parent. So I have this abstract class nested builder typed. I have this abstract method build because this is something I'm invocating later via reflection because I know it's always called build. Okay? Build is for me ending my stuff going back to my parent. That's what's going on. Then I have a parent because I have to redirect. I have to set my parent, or I have to set myself, my children. I have to set me as children at my parent. And then I need a nested builder that's just extending this one. And what's going on here is just I'm setting my parent, or I'm setting myself at my parent. Okay, depending if you're going bottom up or top down. Yeah? So what do you want to do? If you have this one, this is the connection between the different layers because you're switching to the parent and back. Okay. The other side is, you have this nested builder, you have this method done, call it build, whatever. I just want to have a different name, so that's easier to follow during the presentation. If it is done, what I'm doing, I'm getting the parent class loader, or the parent class, and then I'm invoking this build, and then there's a naming convention. This can be a naming convention, can be another strategy. I'm just using a naming convention because then the source code is small, okay? But I say, okay, I have something with and class simple name that I can invoke. I'm using reflection because I don't know who's combining what in which order, okay? And with this naming convention is the easiest way. And then what I'm doing is I'm getting declared methods, blah, 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 invoking, done. Man, that's so much code, not more. How to use this? Oh, here, this one. So here, there's a naming convention. Okay, so if I'm here, the parent builder will hold all child builders. Yes, I have the root, and then I'm going down. Okay. The parent builder will have some add child method, add wheel, add engine, whatever. This is something you have to write. You can generate it with annotation processing, but you have to write it first. Then you have to extend the child builder. It's just to extend the nested builder because the implementation is generic. You have to do nothing. You have to add this add child methods and all this stuff. That's it. It's a delegation and typing. And the rest, no, generated. So how it looks like, I think I have an example. You can be a parent and a child at the same time. Wow. I have the possibility to build a tree of builders with different passes. Okay? Because it's always the same. I can be a parent and a child at the same time. And here's exactly what you have to do by yourself. Huh? You have to do this new builder with parent builder, connecting both. This is something that really is crying for generate me. Okay? And then you have this add child and whatever thing, and that's just giving back the new builder. From type safety point of view, it's freaking easy. Okay. So here, this you have to write, okay? Or to generate, and then this methods. That's all. Not more, because the other part is with extended nested builder done. And if you have this marker extended nested builder, you can work with reflection and do all this magic stuff, but too complex for now, okay? Switching builders. So if I've now this, then how it looks like. I'm extending nested builder, that's the only thing, and I'm done. And then what I can do is, I have a new parent builder, add child and build, or what I can create is, add blah blah, add the next child and go. Okay, you got the point? You can have it as a linear list, you can have it as a tree. Don't build cycles, don't build graphs, okay? But with this, just a few lines of code, you have the possibility to lead the developer in a very straightforward way. So, having this in mind, what's coming next? The dynamic proxy builder. So, one functionality leads to one proxy. Okay, don't mix it up. Runtime overhead for every proxy, yes, because we have this reflection invocation mechanism, just more bytecode. We're optimizing later. So go brute force, create everything single, and then later think about if you really know how it's used and all this stuff, what you're optimizing. Otherwise, it's pre-optimization. It makes no sense. Okay, so the first version of Dynamic Object Adapter was written by Heinz Kabutz, and I will show you what are the weak things there and what we can improve. The Dynamic Object Adapter is the following. You have a proxy, and this proxy have an original and an adapter. What does it mean? So you can invoke the original method, or you can invoke an adapter method. Now I start writing proxies for partial objects because I'm just overwriting one single method. Okay. So let's do. So switching between method implementations. I have this original one. I just want to switch one implementation. That's one thing. How to identify a method. If you're on reflection, what you need, let's say we have the service, and I want to identify the do work A thing, yes? If I want to have this one. The question is, how I can make sure that I identifying this is a method from the original one and this is from the adapter one. And the easiest thing to do this is that you're comparing the method name and the array of all input values, because this is unique, okay? And this is used as an identifier. Let's think about it, that this is your key that you can use in hash maps. And the implementation is a value through this key, okay? So this is exactly what's going on here. So name, params, and then go to a hash map. So we have a few things. This dynamic invocation handler. We have this adapted method, which one I want to override. Then I have the original implementation. I want to switch back if I don't have an adapter for this dedicated method. And I have, in the original version, one adapter. So I could override exactly one method, okay? That's the original from Heinz. If I'm adding an adapter, I'm setting this adapter, and then I'm grabbing the class, I'm grabbing the declared methods, building the key, okay? This I'm doing for all methods, and now I'm building this key and putting this more or less to the hash map, okay? That's just building a key, value pay, and a hash map so that you can identify it. Okay, that's it. So if I'm invoking now something, what's going on? If I'm invoking, I want to make sure that I'm switching between implementations based on what I'm invoking, okay? So the first thing is I'm creating this method identifier based on the method I want to invoke. Then I'm going to the hash map and check if there's something. If yes, invoke, otherwise go to the original. Easy peasy, huh? Okay, but there are a few things I don't like, a few things. So let's see what could be a problem here. First of all, now what could be improved? First of all, if I have this interface and I have this adapter, they are not in inheritance, okay? But if I'm refactoring later, it wouldn't match. And I could add at several points adapters that are completely useless because the original method signature changed. Okay, this could happen because I'm using object, and this is not strong enough. So what I want to have now is that I want to have the possibility, first of all, to give more adapters and make it type safe so that you can use it without any bigger accidents. So let's assume I have this interface with two methods, okay, and I have an implementation that is implementing exactly these two methods. Now, what I want to do is I'm creating an adapter. The nice thing is, first of all, if I'm always adapting just one method, it's per definition always a functional interface. Having it in mind. The next thing is, if I'm working with naming conventions, I can generate all this interface with annotation processing. So much code, and then it's generated, okay? So I have always adapters in a compile cycle that just matching to the implementation. If I'm refactoring this, the next run will change the adapters. Everything in semantic context, well, or static semantics, mean that the compile will break if I'm mixing stuff up. That's the first thing. Okay, this is a functional interface, this is a functional interface. So I'm dividing this one without being in inheritance. So now I have a map of adapters. And what I want to have is I'm getting the declared methods, I'm going over the methods, I'm creating this identifier, I'm putting this to the hash map, and so on and so on. So I'm filling this stuff, okay? Now I know what are the possible keys I have and what's in. Then I'm putting the adapter I have exactly inside this. So I can add now different adapters. Now I'm adding not only one adapter, I'm adding different adapters. At runtime, I can switch adapters, by the way. Huh? It's just a hash map. So, next one. Invocation is exactly as it was done before, creating method identifier, going to this one, identifying yes or no. Done. So, If you're using this without a builder, you can add useless adapters because I have to go over object because there's no inheritance, okay? So I need to find a way to make this type safe. Otherwise, it would open the door to messing up the system. So add some with methods. If I have a builder and I'm creating something like with method name A, with method name B, and I know the corresponding functional interface is exactly what matches, or the naming strategy, easy, I can generate the whole stuff with annotation processing. And then I'm just adding these adapters. So now I have these two methods. I have this adapter. I have this extended naming convention, so that's a scalable naming schema. And then I have the possibility to generate all this, and it's readable by the user because you have class name, method name, and all this stuff, okay? So how to use this? I have this adapter builder with service, new builder, so I'm typing this stuff on the fly. I'm setting the target. I'm setting the original. I'm adding an adapter, even with lambdas, very short implementation on the fly. And I'm building this stuff. So again, combine traditional design patterns. It's easy and it's very, so build in all the stuff that are good design patterns. No? So here I can do this on the fly. Next one, how to use it like a mock without bytecode stuff. I'm just saying, okay, this is a service. I have no original, but for this method, you should do exactly this. Now I have a mock without bytecode magic, without compiled stuff. Everybody's able to read it, okay? And the implementation of this mock is not hidden somewhere. It's part of the JUnit test. And I see exactly, okay, it's doing what I'm expecting, okay? You can use it like a mock without any magic. Okay. Then, I don't want to write all this stuff by myself. It's freaking boring. And all this stuff is declared inside the interfaces and all this stuff. The information is there. It's part of the source code, part of the typing system. What should we change? We have this interface. We have these two adapters, not in inheritance, but I want to bind them in a way that you can't use an old one. Must be refactoring safe, okay? So this one, functional interface, we got it. So use annotation processing, and I created, on GitHub, I have the implementation, so you can check there how it goes. Yeah? But if you have this annotation, for example, dynamic object adapter, then you can mark something with this, and then during the compile process, you're going through all methods, creating the functional interfaces, and so on, and creating the builder. Because it's a straightforward process. You just have to match a few names, okay? And then you can say, okay, don't forget retention policy source and element type. And then you have this interface, dynamic object adapter builder. So the names are long and long and longer. Huh? And then you have to extend this abstract processor. This is too much here to show and go in detail to use an annotation processing, but it's a very clear way to do it. It's documented. It's a straightforward thing. It's a basic thing. It's no additional stuff. It's part of the JDK since ages, okay? So, next one. With every compile, it will generate the stuff new. It was exactly the semantic break if you're using wrong adapters, and so on. So it's more or less what we are doing here. So this was using the whole time dynamic proxy, and the dynamic proxy has runtime overhead because the invocation mechanism is using reflection all this time. How to get rid of this one without writing boring stuff? I want to have now static object adapters. So what I want to use, I have this interface. Okay, I got it. I have this created methods or functional interfaces, right? Okay. If I'm now going over this functional interfaces, who is creating what and what we had with the strategy? And there was something in the beginning of the slides. Huh? So I have now this static object adapter that is implementing. If I'm writing it down manually, I would have the interface, I would have the adapters, okay? Then I would have the method, and for every method, I would just write this, okay? This is what I would do if I would do it manually. Why should I do it the first 1 or 2 times manually? Because you see what's boring freaking bad code, what you want to automate. You need to identify patterns, and the brain is working with pattern matching, visual processing, not this one, reading stuff, visual processing, okay? And this is helping. So write it down, okay? And then you're doing always the same. This is so easy to generate because it's everything symmetric in both ways. If I know this, then I can do all this boilerplate code. I can now add the static object adapter annotation. This is what you should do. And I can annotate everything I'm generating with is object adapter. Wow. Now I can combine at runtime with reflection all this shit together. And during the compile process, I can generate everything. With this, we have refactoring safety. Okay? And no bytecode magic. Because you can deliver source code, you can analyze it, metrics, and all this stuff. Okay. This is everything inside this repository proxy builder. Okay. Then you can play around. There are older stuff from JDK 8, what I removed out of the slides. It would just be endless for tonight, because you can generate all this stuff without round trips over the hard disk in memory. Okay. I can show the slides, but I'm not sure, since some unsafe is not so fancy anymore. I killed this out of the slides. But all the other stuff is part of the core functionality thins 1.3. And it doesn't matter if you're using old syntax or new syntax, if you're using the newest JDK or the older JDK, because it's just part of the JDK, okay? You can implement, build up this stuff, and you can use it endless. Okay, and this is something I highly recommend. You have source code instead of bytecode stuff you don't really verifying. You can go with your IDE through it. You can analyze it, you can train, you can implement all this stuff with what is the right order to implement stuff. You can make it convenient. If you are creating this stuff, not only thinking how cool it is to create, think about how good or bad it's usable for your colleagues that don't want to have this deep dive in all this stuff. But with virtual proxies, you can hide so many things. You can implement cross-domain topics very easily. You are just in still code Java without adding dependencies. Means less vulnerabilities and malicious code packages and all this stuff. Okay? So, any questions so far? Killed by JDK 1.3. Okay. So if you have any questions later, then don't be shy. Just ask. Otherwise, if you want to know more, go on my YouTube channel. I really would like to have you as my new subscriber. It's my pet project. Okay. I started during the pandemic with this, and I just love it. So seeing me outdoors, running around in the Swedish woods and talking about cybersecurity stuff or whatever, definitely not slides with shaking heads. And yeah, don't use email, use Twitter, LinkedIn, all this stuff. Don't forget to tweet about this event to give him something back, okay? Because he organized all this stuff and all the other JUG leaders. And did I miss anything? Who tweeted already? No. Okay, you have a task now. Good. So I'm done. Thank you very much.
Thank you, Sven, for this talk. I think we need to review it in replay. So thank you very much. So any questions? No?
I miss, maybe because we don't have time, but probably you have in mind. But I miss it to check that a proxy is not a cycle reference, no?
Yeah. So what I excluded here.
Sorry.
Yeah. So the question was how to make sure that you're not building graphs. So lists, okay, trees, okay, graphs are bad. So means you can do it inside the builder if you're just checking references. You can make sure that inside the builder, the possibility of invoking several things twice is not working or is overwriting or whatever your strategy is, okay? Covering here all the detection methods would sit here the next hour. Too much. But yes, it's your, more or less your task to make sure that with this strategy, how you're offering this functionality, it's more or less easy and without any bigger accidents usable. If you're just using proxies, they're messing it up. If you start with builders, you get structure. If you're working with cascaded builders or nested builders, it's way easier to do, okay? And you have to find your balance between making it comfortable, maintaining this stuff, versus just, hey, my colleagues are not completely stupid, okay? So this balance, you have to find by yourself, and it's really independent from project to project different, okay? But I think I gave you enough level so that you can identify which one would be interesting for you, and then try it. That's the best thing, try it, okay? Any other question? No?
Okay.
Perfect.
Just in Spanish, I'm going to...
Yeah.
Bueno, gracias por venir. Vamos a despedir el JUG y nos quedamos que va a haber un sorteo de un par de cosillas, pero cortamos el streaming. Y lo que quería decir es que la semana que viene tenemos otro JUG donde 2 personas nos van a hablar de cómo refactorizar aplicaciones cuando no se tienen test. Seguramente conocéis proyectos donde es el caso. Así que nada, sois bienvenidos y nos vemos la semana que viene.